Welcome back. Problem 7-2. This problem is taken from chapter number 7, Internal Forces, and book name is Statics and Dynamics by R.C. Hibbeler, 14th edition. So statement is determine the internal normal force and shear force and bending moment in the beam at point C and D. Assume the support at B is a roller. Point C is located just to the right of 8 kips load. So you can see this is a simply supported beam having a point load 8 kips, and there is a moment which is 40 kips into feet. So you have to determine the internal loadings, which means internal normal force, shear force, and bending moment at point C and D. B is a roller support and point C is located just to the right side of this 8 kips load. So let's start with the solution. The first step is that if you remove this pin support at point A, so you will be having a normal force which is AY, as well as you will be having a horizontal reaction force which is equal to AX. Similarly, if you remove this roller support at point B, so you will be having a vertical reaction force which will be represented as by. So we'll find this AY, BY, and AX by using equation of equilibrium. So first equation of equilibrium is that sum of all forces along x direction must be equal to 0 and force toward right side is taken as positive. You can see only one horizontal force AX is acting. There is no other force. So it means that AX is equal to 0. Now we'll find this AY by using the second equation of equilibrium, that is sum of all forces along y direction must be equal to 0 and upward force is taken as positive. So you can see AY which is acting upward minus this 8 kips load plus this BY is equal to 0. So from here AY plus BY is equal to 8. So both are unknown, so we will take this as equation number 1. The third equation of equilibrium that we will be using is that sum of all moments about point A is equal to 0 in order to find the by, and taking the counterclockwise moment as positive. So about point B, A, the first moment is due to 8 and perpendicular distance is 8 feet and it is producing clockwise movement, so it will be taken as negative. So I can write it as 8 minus 8 multiplied by 8. The second movement is due to this by and perpendicular distance is 24 feet and this is producing counterclockwise movement, so it will be taken as positive. So I can write plus by into 24. And the last, you can see you have external movement which is also counterclockwise, and that is plus 40. So I can write it plus 40 is equal to 0. So minus 8 multiply 8 is minus 64 plus 24 by plus 40 is equal to 0. So minus 64 plus 40 is minus 24. So by will be equal to, I can write is minus 24 plus 24 by is equal to 0. So it means that 24 by is equal to 24 and by will be equal to 24 by 24, which will be 1, and unit will be kip. So we have find out this by, and the last thing is that if you want to find AY, so put by is equal to 1 kip in equation 1. You will get AY. So AY will be equal to 8 minus by, and 8 minus 1 will be equal to 7 kip. So we get AY is equal to 7 kip. So these three are the reaction forces. I will highlight them: AX, BY, and AY. Clear? Now what we have to find is that, as we have been asked to find the internal loading at point C, so for that we will cut this beam at point C, clear, which is just to the right side of this 8 kips loads, and we will draw the free body diagram. So for segment AC, the free body diagram will be like this. Is the beam, clear. Here you have AY, which is upward AY, and at this point you have 8 kips load, and this is your point C. So when you cut it, you will be having a normal axial load, which is NC. You will be having shear force, which will be VC, and there will be a moment which will be MC. The direction of this MC is counterclockwise, is due to convention, and VC is also taken as downward. So we'll find them one by one. So how we'll find it? So for first, for horizontal force, we will apply the equation of equilibrium, that sum of all forces along x direction must be equal to 0, and force toward right is taken as positive. So only NC is acting horizontal, there is no other load, so it means that NC should be equal to 0. Now we'll apply the second equation of equilibrium for finding VC, that is sum of all forces along y direction must be equal to 0, and upward force is taken as positive. So first force is AY, which is 7 kips. So 7 kip, that is upward. This minus 8 kip, which is downward, minus VC is equal to 0. So it means that VC is equal to 7 minus 8, which is equal to minus 1 kip. So I can write VC is equal to minus 1 kip. Now this VC is minus, so assumed direction is wrong. I will write it, assume direction is wrong, and VC should be upward. So I can write the correct answer, VC is 1 kip, and that is upward. This is the internal shear at point C. Now I'll find this MC by using the third equation of equilibrium, that is sum of all moment about point C is equal to 0, and taking the counterclockwise movement as positive. So you can see from A to C distance is 8 feet. So this distance is 8 feet. So the first moment about this point C is due to this AY into 8 feet, and this is producing clockwise movement, so it will be negative. So I can write it, AY is 7 kips multiplied by 8, and this is clockwise, so it will be negative. And the internal movement MC, which is taken as counterclockwise, is positive, so I can write plus MC. There is no other moment, so their sum must be equal to 0. So from here we can find this MC is equal to 7 8s are 56, and the unit will be kips into feet. Since this is a positive value, it means that our assumed direction is correct. So we have find out the internal normal force, shear force, and movement at point C. Now what we are going to do is that we are going to find at point D as well. So what we will do is that for that we will cut this beam at this D, and we will take this portion for our analysis purpose, and we will draw the free body diagram. So for segment DB, I will write for segment BD or DB, I will draw the free body diagram over here. So this is the beam, clear. This is your point B, and this is your point D. And at point B, you have a vertical reaction force, which is By, and that was equal to 1 kips load. And there was a moment, there was a movement as well which was 40 kips into feet at point B. Let me show you here. This is the 40 kips into feet. And when you cut it at point D, so you will be having normal axial load which will be ND. So you will be having a shear force which is VD taken upward on this section, and there will be a moment that will be MD that is taken as clockwise by convention on this right side section of the beam. Now we'll find this one by one. For first one, we will apply the equation of equilibrium, that sum of all forces along x direction must be equal to 0 and force toward right is positive. So only one normal force, horizontal normal force, that is acting in opposite to the positive axis, and there is no other load, so it means that minus ND is equal to 0. So from here we will get this ND is equal to 0. The second, we will find this sum of all forces along y direction must be equal to 0 and force toward upward is taken as positive. So By, which is acting upward, is 1, and this Vd is also acting upward. So this Vd is equal to 0. Both are positive, so it means that Vd is equal to minus 1 kip. So minus means that our assumed direction of Vd which we have taken upward is wrong. I will write assume direction of Vd is wrong. It should be downward. So our correct answer that Vd will be equal to 1 kip and it will be downward. Okay. Now the last thing is that we will find this moment about point D. So for that we will apply sum of all moment about point D is taken as 0 and taking the counterclockwise moment as positive. So distance between B and D is 8 feet. So I will write it over here. This distance is 8 feet. Now the sum of all moment about point D is equal to 0. So one load is By and perpendicular distance is 8, is producing counterclockwise moment is positive. This 40 kips is also into feet is also positive, and this clockwise MD is negative. Their sum must be equal to 0. So I can write minus MD plus 40 kips plus 1 multiplied by 8 is equal to 0. So it means that MD will be equal to 40 plus 8, and that will be equal to 48 kips into feet. So MD is 48 kips into feet. So this was the internal normal force at point D, internal shear force at point D, which is 1 kips downward, and the bending moment at point D. And that is all about this problem 7-2. I hope you have enjoyed this video and you have learned from it. Those who are new to my channel, then subscribe it and don't forget to press the bell icon so that you can get notification about my latest videos. If you have any question, you can ask me in comment section. Thank you for watching.